So I'll talk about smart energy, and I work for Northern Powergrid, and because the energy sector is so very fragmented of a supply chain, I thought I'd share a chart to show where we sit on that supply chain. So we operate the electricity network from extra high voltage taken from national grid lines down to the cables coming into, your homes, which is low voltage. And typically our bill is about £85 per year, and we happen to cover the Northeast, Yorkshire and North Lincolnshire, but there's 5 other groups that cover the rest of England. So what I've thought I'd do is to demonstrate through a few examples that technology can help avoid the dystopian future, in the sense that it can help prevent it from happening, it can help protect us from its effects, and just for the sake of completeness, and just like Alex has just did as well, I want to consider the fact that technology is only part of the solution to avoid this future. There's more work to be done. So just in terms of prevention then, the first one is enabling the net zero targets that this country has signed up to. Those targets for us as an electricity network mean that much more, in fact, low carbon generation and technology will be connected onto the electricity network. Alex has talked about electric vehicles, that's an example, batteries. And then there's also some modeling that show that more than double the amount of the current renewable generation will have to be connected by 2050 as well. So how do we play our bit? It's the example I've given here called auto design. What it is it's an automation of engineering design. Yeah. So 2 months ago, we've introduced this tool, which is a free online platform that provides budget estimates for any new low voltage connection. So anybody who wants to connect, say, an electric vehicle or a small battery can use that tool. And from a technology perspective, it's not disruptive because it just links a map to an electrical design software that optimizes the work that a design engineer would have done in about 10 days. And instead, the customer gets a budget estimate in, almost real time. So that's a massive improvement. And the benefit for society is that it accelerates the deployment of electric vehicle charging points, for instance. So that's one example of a technology. The other one that I wanted to introduce has to do with maximizing the use of existing assets. That's the point of sustainability that's been done before. Let's not hurry into building something new. And instead, let's look at making the most of what we already have at our disposal. So what I'm talking about here is a technology or a group of technology that optimizes solutions through data collection and analytics. Again, not so much disruptive because it's about data computing, but a massive improvement from a sustainability perspective. So, I share here a table that describes the type of technology that we used. But basically, what you need to know is that it's a mix of hardware that we put onto our assets, combined with a power system analysis tool that makes the right decision on the operation of our networks, because it's informed by the real-time conditions of the assets rather than by standards, engineering standards and assumptions. Again, in Northern Powergrid, we are deploying such a program and talk a lot about, the £1 million benefit that it will help us deploy for our customers. And then the last example I wanted to give was on managing the demand side. Here, it's about avoiding to build new assets by instead incentivizing the customer to change its consumption behavior And here the technology is used to exploit the principles of the nudge theory, right? So an example that we've deployed is using a mobile phone game to incentivize households to reduce their consumption at peak time. It was an innovation program called Activating Community Energy, ACE, and people were competing for cash prizes by turning off their washing machines, their televisions, lights, and other sorts of home devices when we were telling them to. And what this project has demonstrated is that keeping people interested through a game rather than through the message of sustainability is achievable, and the results were that people were cutting their electricity by an average of 11%, which in some situations is good enough for us not to have to invest in more costly electricity assets. Okay, so moving on to my other point, which is that technology can help prevent this dystopian future by mitigating its impact. The fourth point is classic climate change adaptation strategy. Our strategy for now is quite robust, but it's pretty standard. It's about adapting to extreme weather, such as flood risk onto our substation, high wind causing overhead lines to fall. The technology here is not necessarily advanced or disruptive at all. There's a lot of civil engineering involved. I did want to make a reference to another theory that some people are developing, which is that there's another way of expanding our imagination around technology to adapt to climate change, which is to make use of science fiction narratives. It's an exciting but quite a serious theory, and I give a reference in the last slide here if some of you are interested, but I won't expand on it. Just coming back to the energy sector, in terms of increasing local resilience, I just wanted to touch base on community scale microgrids, which probably a lot of you will be familiar with this idea. In terms of technology, it consists, again, in optimizing solutions through data collection and analytics. What's interesting here is that we're talking about integrating energy generation, storage, usage, so that it can be both connected to the electrical grid or can operate in isolation or as an island. And that's where the resilience value resides. The fact that resilience is not delivered through asset redundancy, as we have pretty much been doing until now, but rather through smart control of those multi-vector, we call it, energy systems. Multi-vector means that it's about electricity, heat, gas, and combining all of that. And really, if you look in terms of disruption, smart grids are well known and understood, but the real next step or progress in that is in finding a way to integrate and replicate those multi-vector microgrids. And then just one point I wanted to make. I wanted to make sure that I addressed the point of social inequality. And this time, it's by using customer data rather than asset data. So the technology is quite simple. It's about data analytics. But the effect could be very important for our customers. So knowing who our customers are through a compilation of various data sources really does help us make practical consideration regarding the provision of our services. So I give the example here of our social indicator mapping tool, which, for instance, has shown us that in 2 of our 9 operating zones, more than half of the population is in the UK top 30 of poverty. And knowing this and knowing where they are, down to the postcode means that we are actually doing things very differently when we carry out repair works and responding to a power cut, so that we look after those customers in a different way that is much more customized and adapted for them. And just really in the last minute that I have, perhaps, I just wanted to make this point that solving those big issues cannot be done by technology alone. And there's a very interesting theory developed by an academic called Eugenie Morozov, who warns us against this. And again, I give a reference in the last slide if you're interested in this proposition. But so for energy, it means that we need to think about the list of things at minimum here. So in terms of education, the need to educate the population shouldn't be forgotten. So apps, such as the Gen game that I've talked about, where people play on their phone, is interesting for achieving our goals, but it means that participants do not need to understand the wider context of what they're contributing to. And it makes them a customer and a gamer before being a citizen. And we're losing sight here of the environmental and ethical dimension of our goals, and it's probably not ideal. So let's not forget about education. The other point is about regulatory reforms needing to address the big questions. So how is this new vision of an energy system going to work from a market perspective? Who should be in charge? What customer protections do we want to put in place? All of that needs to be considered. Third point, there's difficult political decisions that need taken by an elected government. It can't only be done, it can't only be in the hands of private companies like Google's or like Northern Powergrid. Those decisions are of the type of, how much can we afford to invest as a society? Who is going to pay for this? There are all things that need to be tackled by ideology and explored through debates rather than through a quick fix technological solution. And then just finally, the last point is that we do need to invest in infrastructure. Technology is good at optimizing what's there within the constraint, but what about changing the constraint to begin with and, getting rid of it? So in the energy system, it'd be, for instance, about creating more capacity on the network and investing in those big assets. So that's just my last slide to say that I've spoken very generically about our action and some of the technology. I've not gone into detail, so I just wanted to highlight the program of engagement that we have coming up in May. A couple of hours forums where you could get a chance to hear about more of this in the detail, but also, and more importantly, give your opinion and help us share our future plans. So that's the end of my presentation. I think I've slightly overrun. I'm introducing Colin and George now. Perhaps, Ben, what I can do is not look at the question just now. Let Colin and George do their presentation so we don't run too much over time, and then take any questions later if we do have time live, and if not, I can do it in writing.
I don't mind. I mean, if you just want to have a quick look, it's okay. We do have a bit of slack built into the schedule.
Okay.
So, I mean, I think it's better to pick them up live if possible.
Okay, yeah. So, right, so the first one, similar software for commercial offices. Probably, it was developed by a partner of ours called Gen Game. I'll give you the reference, and they might have it in their product portfolio. I'm just not aware of it, Gemma. So let me pick that up with you, and I'll send you the reference in the chat box. Oh, same question from that phone, the Galaxy phone. Yeah. So the main resilient risks are, I've talked about climate change. There's also the risk of introduced by more renewable generation in the energy mix. That means that from an electricity system perspective, power quality is affected. So that's another thing that we need to take into account. I mean, I'll provide an answer into a bit more detail. Energy and active discussion. I've read that without nuclear, we cannot provide enough carbon energy to allow for continued. Yeah, energy supply isn't, so the risk of not having enough energy generation is really one for government to consider through the kind of the program of initiatives that they'll be putting together to support those net zero initiatives, right? Because we've announced a set of goals, but how are we going to achieve it while maintaining the quality of our current standards? That's not been explained yet. So you might be right that without nuclear, there won't be just enough low carbon generation, except if there's enough incentive for the market to provide them. So unfortunately, that's still up in the air.